hello, Friedrich, and
Hello,
please start.
Andre. Thank you for the introduction. So my name is Friedrich Keul. I've worked at universities and the pharmaceutical industry. I've with Elsevier now for 2 years, and I would like to introduce you to Elsevier's IT solutions for research and education at universities. It's not really covering all the solutions, but I will touch up on the reaction flash app, Reaxys MC, so Reaxys medicinal chemistry, and how it is linked with Scopus. But before I do give you some case studies, I would like to just share the view we have at universities. And we think your mission is really primary mission of universities and science institutions is education. You want to educate, that's for sure. Your second mission is, and that is not least important, is creating knowledge. The tertiary mission is progression of countries, your country, mankind, and to innovate. That's very important. We publish a lot of your results, and we feed actually our IT solutions with this information, and that's quite important. So the more you innovate, the more we can give back to you. And in our view, so academic institutions must be profitable in educational terms, not so much in financial terms, although they depend heavily on public funding. Can be federal, regional, states, private and public organizations, alumni, and many other groups. So there's always a focus on this. Indeed, and success of an educational institution is a competitive bid for talent, funding, infrastructure, and connections. So universities need to attract top staff, postdocs, and students to be successful, to boost their institutional reputation and ranking. They need to foster interdisciplinarity and innovative research. They demonstrate a vision, which is very important, and invest in the structures for the future, particularly how to circumvent or to the challenges of new areas are coming. For instance, the global climate change could be one. It could be as well new diseases. So, and create an effective lab training, classroom state of the art is very important for you as well. And nowadays it's very important as well to engage with industry, governmental institutions, other institutions to set up projects that are really serving society. And on the other hand, so that means really then increasing competition as well, because the number of students globally are increasing constantly. And at the same time, and I mentioned it already, the funding is very important for universities. So that's more or less stagnating globally. And so how do you get the funding? You require to have proposals that are of high value to the funders. And when you look at the success rates of the application rate, you see that globally, and most of the areas I'm showing here is really the rates are below 20%. So you need to apply quite often, 5 times, I guess, to get one to be successful once. And we ask at Elsevier as well, what's actually creating the pressure, and how likely is it that this pressure to publish, which is very important for the funding organizations to move projects forward and get the funding. So 2,000 of scientists, researchers at universities answered that it is likely or very likely that in the coming next years or 10 years, the pressure will increase. And the next question should be then, who is applying this pressure? You can imagine it's actually the funding organizations. They want to see that you're already successful. And certainly the research administrators, which are directly linked, they would like to have you publishing as well, applying pressure so that you do, and potential employers for sure as well, because they measure success of candidates by the number of publication and the quality of publications. So that we need to bear in mind. And when Elsevier would support scientists of various disciplines in the design, make, and test cycle, it is required to gain knowledge, and this knowledge we provide. So in the design phase of a project, when you are talking about chemistry, it's important that you have high quality literature research and that you do the synthesis planning very carefully. And you don't need to rerun synthesis all over again to be successful. And then certainly, again, you need to source reagents, execute the synthesis, and confirm the identity of compounds you're synthesizing. Then after that, after you have collected the compound and purified it, you need to really plan and test your hypothesis. Is it really right? What you predicted by measuring properties of the material you synthesized. And then after you analyzed and visualized and understood what you've provided, you have a new starting point for a new idea and to build up on the knowledge you actually created in-house and with published data. And we provide really at Elsevier this public knowledge, which as well comes from you and through your publications. We have a large portfolio of products, and today I will focus on just a few. When you look at this life cycle at universities, get funded, innovate, publish, collaborate is very important in gaining reputation. So, and then start all over again. There are many products we're covering. We have Science Direct, which actually serves all phases of these projects with about 1 million articles actually in open access. Today, I would like to, and at the beginning, it's funding institutionals. At the innovate stage, we have Reaxys medicinal chemistry. I will lay my emphasis on in the presentation on it, and Reaxys, other products like Mendeleer, Cyval, and Pure. Cyval and Pure, so competitive intelligence tools we provide, so you can measure how you rank to others. You can find collaborators, and I would like to begin, but not right now, with Reaction Flash, which really gives you a very good overview as an organic chemist of named reactions in the literature. So let's animate that a little bit more. So we would like to enable your research. Doing your research, we would help you sharing research. We have as well products, as you see, Mendeley is a free product to share literature, and you need to gain a reputation to have the right possibilities to get the funding required to do your research, enabling it in a way. So get funded. We have in funding institutional, innovate and acquire, Scopus, Reaxys, doing the research. Reaxys medicinal chemistry helps you. Sharing the research as well is Cyval, a very good tool. Competitive intelligence. Scopus helps you along with publishing and protect your IP and reputation. Finally, collaborating. Cyval, as I mentioned, and Pure are key elements of the portfolio of Elsevier's IT solutions that can help you. In the end, we would really like that you increase your knowledge to innovate, stand out, and obtain the higher funding. So this is where we come from. And now I would like to go through a few examples. I have 3 examples. As I mentioned, I would like to start with the Reaction Flash app, which is a very useful tool. It is free, and let me introduce you to it. I'm not sure you know all of it, but let's have a look at it and how well it is suited actually as during lectures of organic chemistry as an educational tool, or you educate yourself in preparing for examinations if you're required to know a lot of named reactions, their reaction mechanisms, and how to apply these type of reaction. It is clearly very much closely linked to Reaxys as well. All the information, most of the information on Reaxys is coming from there. So if you need to learn about named reaction, just download it. If you want to use it in lectures of organic chemistry illustrating examples, then you can use it as well. You can, all the students can do it and understand the reactions on their phones if they have. Need to check named reaction, you don't know how it was like, then you can go to the app and go in there. It's very simple. Organized, we have these drawings, they all come from us, created by us. So a simple reaction like this reduction is depicted, the conditions are on there. We have quizzes to be run, so you can run a quiz. If you would like to learn or test your knowledge, if you like, and it is linked to Reaxys. If you have access to Reaxys, just need to click on one of the links and you will obtain all the literature examples on a specific reactions, most recent and all the ones, depending how you filter. So currently we have 1,000 plus named reactions in there. Per year, maybe 200 are added. It's available for iOS and Android devices, and it's absolutely free. And you don't need to be connected to the internet when using the app. Over 80,000 downloads of the app already worldwide. We have excellent ratings for it, and feedback and recommendation on content and app extensions are welcome. So please go and download it today if you can. Just give you a little bit of insight as well, who actually did the work. Besides Elsevier, we have a very strong collaboration with Professor Dr. Eric Carrera. He is a board member of the Reaxys PhD prize as well. I know him well, and his team, they started to develop this. We have a guidance team of 18 students who are involved developing the user experience, how it should be. So it's really made from organic chemistry, chemists to chemists. So it's really something which is absolutely probably convenient use for any chemist who is in education or even further ahead. So the quiz strategy was developed with guidance from teaching instructors as well. And so now I have a small video for you. I hope this is working. I've not tried it in a Zoom meeting yet. I've recorded this on my own phone. And it gives you 3 examples of the reaction flash by Reaxys. Please let me know if it's working, Andre. I will start it now. And I will give some comments what's happening on the screen. It's not with sound, actually. So it should start now. So what you see here, it's the long list of different landscape you can put. The quiz duration you can change from 10 to 60 minutes. You can look at the ratings, for instance. That's really important. You can rate it yourself if possible. That would be great. If you give it a high 5-star rating, would be great. It's constantly updated. Now I'll give you an example of the Baeyer-Willinger ketone oxidation. Here you see a typical example. It oxidizes to an ester, and ketone can be done as well. Down there, there is a possibility to look directly at the mechanism. You see enlarge it. You see that there, here how the mechanism of the Lewis acid and then exclusions and rearrangements lead to the ester. This can be then as well visualized in Reaxys. You just need to go down there and see the list of different literature examples, for instance, tetrahedron, the conditions, how long it took with ozone. And then I've given an example in organometallics, and it shows Pawson-Kant reaction. Here we see an alkyne with an alkene and cobalt octocarbonyl leading to a cyclic structure. The mechanism again shows stereochemically correct. The formation of this cycle, very useful, I think, because it's complex. And if you go now directly to Reaxys, first of all, we look again at the literature examples. And see here the conditions, how it's done in THF, and then going to Reaxys actually performs the search automatically, post and country reaction, and you find certainly far more reactions. The recent examples on top of the list, with all the conditions, how it was done, at what pressure, how for long, and this certainly detailed information already leads you to an idea how you would perform yourself this type of reaction. Gives you clear ideas. You don't need the literature, particularly the paper not. And then last example, the classics, like I chose Robinson annihilation. You probably know that's a Michael addition and aldol condensation. And here the mechanism of it. Two-step reaction is very well known. It forms bicyclic formation of rings, which is then as well a nice starting point for other chemistries like a Michael acceptor we have here. So in the end here again, you see conditions, yields, and possible ways to extract more information from Journal of Organic Chemistry or whatever. It's listed in this short list, and going to Reaxys immediately will lead you to far more literature. In addition, if you yourself invented a reaction, would like to suggest it, you can contact the team that is responsible for it, just give the literature and you've done it. So thank you for downloading it. Would be great to see many people using it in combination with Reaxys. It's particularly useful. So if there are at this stage any questions, you can raise them if you like, or we go to the next example. And I've chosen, because due to the times now, a COVID-19 example, academic drug discovery. And that certainly requires Reaxys, and the high quality of Reaxys informations involve the pharmaceutical activities of compounds, which are stored as well. And you can extract those. Let me then start with it if there are no questions at this stage. So drug discovery in academia is possible. Certainly in pharmaceutical departments it's done. But how do you want to start if you have no high throughput screen available, for instance? What you need to have at least requires a working hypothesis, at least an idea. For instance, you would like to fight as well the COVID-19 pandemic. And how could you use Reaxys to accomplish this and to find this? Find a starting point for such a research project. So you need to have a target. You can find that actually in Reaxys. Reaxys provides a lot of target data. Targets are proteins, DNA, and RNA, and indeed as well the activity of small molecules towards these targets. It's available in Reaxys. What you need as well to confirm the activity of compounds you're synthesizing yourself. So it's an in vitro assay or a test, some sort of a test is required. So that needs to be established, or you find somebody who is actually able to establish such tests. It requires certainly the compound synthesis facilities, so you should be able to synthesize compounds, and that is most often possible at universities with chemistry departments. So the high throughput screening already I mentioned is available just through cooperation with big pharma or specialized academic institute. And normally corporations are taking all the intellectual property from academia when offering HTS. So this cooperation can be a tough one for if you want to monetize on your invention. So you don't like that. So what the question is really, what is appearing, how do you start a drug discovery project without a specific target, HTS or lead structures using Reaxys medicinal chemistry? So that is the set that as well contains all the target information, assay information. For this, you need to start with a little understanding of biology and of viruses. So, and this slide summarizes what you need to consider when starting to search for a medication or a starting point for a medication against COVID-19 in Reaxys medicinal chemistry. COVID-19 is a retrovirus. It contains RNA. That's a simple fact. But there are other as well, coronaviruses like SARS and MERS, as you might know, that are very similar to the COVID-19 retrosign. The mechanism of the infection is comparable between the three viruses. That's very important because if they are comparable and the sequence are very similar between those, the proteins they contain that are potential targets as well are very similar. That means all three viruses use their own but highly related viral proteins to alter the activity of human cell activities. Viral modulation of the activity of human proteins in lungs can lead to severe disease states and death. We know that. But, and that's now critical, against SARS and MERS infections, medications are known or in development. Due to the high similarities of the virus and their proteins, molecules against SARS and MERS infections can be a starting point to develop remedies against COVID-19 too. Now the question arises, how can we find this information on the structure-activity relationships of small molecules against SARS and MERS, which are likely to be as well a good starting point to remedy COVID-19 infections? And that's what I would like to introduce you to now. It's a more complex workflow, but not too complex that you can't accomplish it. So searching means not using the quick search, which I show in my second example, but the query builder. And the query builder is just here by me shown like this. I'm searching in the title, abstracts and keywords for novel coronavirus, new coronavirus, COVID-19, and should contain it. In a second group, you don't need to group them, but you could keep them in one group. I search in all keywords. First of all, for SARS-2, SARS and MERS, and this should be identical, because if it just means it is containing MERS, then you probably will find all the literature on polymers as well, and you need to be aware of this. So, and other keywords that are quite important in this search flow. And then it's a very simple step. You just click on documents and gaining 20,000 documents that contain 600 targets. These documents contain all the words I already typed in, but they are not necessarily all related to SARS and MERS remedies. So you need to select now, going to targets, and make a filtration process. Reaxys provides you with a significant number of filter functions. That is due to the fact that it is really highly organized data and curated data, hand depicted. And what we need to do now is very simple thing. We go to target species. We would like to select all those that are just related to coronaviruses or coronaviridae, not to human. And that's I've done here. I limited to human respiratory syncytial virus, human coronaviruses, all subspecies of the coronavirus, and limited to. This leaves us with 57 targets, and they are all contained in SARS coronaviruses or the MERS coronaviruses. Already in this list of compounds, or let's say targets, in this list of targets, you see on the right-hand side the most active substance against these. And they could all be a starting point for a COVID-19 project. If you like, as a target, the 3C cysteine protein as a potential good target for the COVID-19. But it's better to have a full overview of all the information. And Reaxys actually provides the full overview of it by using the heat map. The heat map is up here. It's something you click on, And then it asks you to present the data in different ways. I've chosen x-axis are the targets, that are the proteins in this list. 57 targets. In the y-axis, we have the substances, and in the fields, we find the activity measurement. So apply there, and we find this list. The navigator shows you a total view of it. You just see the top part of it. And in order to get that in order, you could, for instance, select the spike glycoprotein, which is a very prominent example in the COVID-19 infection chain. So the spike protein is absolutely required. The virus is interacting with, and if you click on this and say sort by activity, then you have on top those two molecules that are tested against the spike glycoprotein and are within Reaxys database. If you click on this dot on the left-hand side now, where all the substances are listed, and you can go back to Reaxys. Now it's one in the breadcrumb tree, and you see that this highly active compound is a peptide interacting with it strongly. You can check on the bioactivity. You find the literature is from 2006, so already 14 years old, and it has got a very high activity against this spike glycoprotein, and is very well suited actually to be modified, and it is very likely that it's actually as well active against the COVID-19 spike protein, which as well exists. So going further back to it, you can do in a different way. There are other compounds as well in this long list. You can immediately from the heat map as well obtain data. For instance, this compound has a low activity against a specific proteins, where it is published, how it was tested, what was the target, and assay descriptions you can find there as well. Most important as well for you, if you want to get a better overview and would like to do that not within Reaxys, you can export the data. All the data can be exported and then certainly looked at in thorough. All the information is downloaded into Excel, and you can use that as a starting point to get an idea about the structure activity relationships against specific targets of specific compounds already tested. But probably once you've done such searches, you have already decided what you would like to work on. So you might have an assay of a collaborator, maybe this one here, the replicase polyprotein I've chose, and you would just like to see all compounds that are active against this compound. So you can limit to this selected protein target. That could be a good target as well against COVID-19. You sort again by activity and obtain the list of all compounds that are now active against this protein. And that's a very, very long list. It starts again with a peptide-like compound and allows you now to download this and get a thorough view at the activity. What do you see here now? So it downloads into Microsoft Excel. There are other formats as well available. You can add other points like calculated values like the drug likeness, how much they follow the Lipinski rules, for instance, and you download this again into a structure activity relationship you can establish by a graphical representation. All these dots are activity dots, and all these dots represent a different structure. That gives you access to structure activity relationships and a good starting point against, for instance, this protein to start your own COVID-19 project. So I would like to stop here at this stage and would ask Andre if there are any questions on this type of analysis or starting point of relevance. Andre, is there something? Good. Okay, I can send the link to the, I guess it was the Reaction Flash app. That's all. So next step and lastly is starting with how to solve future science challenge like the new energy storage options. How do you find the information within Reaxys? Reaxys contains really very well curated property data of compounds. It's really not comparable to any other database available at this stage in time. So I would say it's excellently suitable to have to solve these problems, to find the information quickly and smoothly. And I give you an example, for instance, from if you would like to find compounds and yeah, properties of compounds that are very relevant, for instance, for energy storage options. We can find very simple here. This gives the content. I don't go through this because it's just illustrated here again in screenshots. So you can see you can, with a quick search, you can immediately start with just using this terminology, energy storage. It will immediately find thousands of documents that contain this energy storage term or phrase. If you view the result, you get certainly the whole list of it. If you would like to know what is the most relevant for others, then you could as well use not sorting it by publication years, but you go to cited by. Then you see the document that contains the phrase I put in at the beginning, energy storage, which is most cited. The materials for electrochemical capacitors is the most cited one. But since we are I'm more on the lookout for, let's say, batteries or something, have a look at this electrical energy storage for the grid, for instance, and click on this. See, this is highly cited as well. Can have a look at it, find out about what's actually the content, and see whether it's worth actually finding or reading it in the context of your own research. Most important, and that's done again in the filter section of Reaxys, and you should use that as often as you can to get trained in it, because the Reaxys tree is something which really helps you to identify very quickly the publication that you are looking for. So going now forward again, oops, going forward back and into the Reaxys tree, you can, for instance, if you are particularly in this subject field interested in the photovoltaic effect, you just select those publications in the long list of 100,000 publications that are using this term as well in the Reaxys tree. The index term tree is very important in Reaxys. So you are ending up with this one, and you probably see immediately that now we are homing in on the interesting bit when it comes down to energy storage and the material with specific activity in the field, and to find the right information for your research. So going further on, looking at, for instance, selecting 3 publications from these, you can do. These 3 documents are now selected. As you can see in the breadcrumb tree here, we have started off with 105,000 documents. We limited or filtered to 8,800 and selected 3 that are most interesting. Top one is cited very often. Again, all of them are very often cited because I'm sorting here. Certainly by looking at one of these, redox flow cells for energy conversions, I'm interested in. I see when it was published. And if you now would like to know a little bit more about who cited it, you just need to click on these numbers, how much is cited, and you will be linked out, if you have access to Scopus, to those documents that cite this redox flow cells for energy conversion. This can be of high interest to others because publications, very recent publication that uses this paper as a reference, could be as well very interesting in the subject matter you are interested in. What you find as well is all the documents that have open access, and you immediately, when clicking on this, will find the first 6 and all the others that are open access, which you're probably interested in as well. So that gives you the first idea of what's available. Going back then to Reaxys to refine your research as you liking, you just need to click on the initial hit rate of 104,000 documents and then start the filter process to your liking and select those papers that are most interesting for you. So I have as well at the end here the same subject, a little part of using the query builder because it's a very important tool in Reaxys. You can limit direct substance properties to a certain topic as well to values if you like. I didn't use values here. I just wanted all substance properties that contain a specific term. I used in this case, in this search, that it should contain the terminology voltaic. So it should have values for this in the publications and would like to check on these. So searching for documents like that will result in even more documents here. And again, you need to filter out by using the Reaxys tree if you would like to home in on those publications that contain really photovoltaic information and some other terms. And this is then by doing so going into, again, the Reaxys tree and using, in your case, might be, in my case, it would be electrochemical cell. I'm interested in electrochemical cells that can be used to generate energy and select those from all the documents I've already know that they contain compounds that have activity in the photovoltaic field. So limit it to it and obtain these documents. And indeed, at the top of it, they really, the first 3 are showing us really the effect of Nafion, membrane fouling on the power generation of a microfuel cell. We see other papers that are highly interesting and very recent ones, certainly, because it's really ordered now by publication here. And again, you could go and use the citation, publish, sort by citation. You would get the most cited one in this list if that's of interest. So this is a different way to approach this. It is maybe more sophisticated, but it does indeed bring you very quickly to the papers are required to start research, to understand scientific relations, and to go ahead with your own research and learn about it. I have a last slide, which I think very important, because that's really on properties in Reaxys. You have seen already medicinal chemistry example. You see here one example in electrical applications and energy storage. The databases are all different available. But what I know about Reaxys, that it really surpasses all the other IT solutions available when it comes down to property searching. The material science like energy storage and on properties of metals are needed. Reaxys has very well curated, always up-to-date property information. It's done weekly or daily even, these updates on the properties of compounds. Reaxys informs about measuring conditions, and that's very important. It does not just state a certain number, it just tells you under which condition it was measured. So pressure, temperature, solvent, and even the outcome, certainly percentage of yield and so on, is always visible there. And I hope I could illustrate that it is a fast process. It needs some training. That's part of it here. And I would like to suggest 2 readings which are very important. One is very recent from this year, Journal of Chemical Education 2020. property information in substance records in major web-based chemical information data retrieval tools is by Damon Ridley, and co-authors as well. The first one, understanding the similarities and differences between databases and chemical information, is very important, and I recommend it to understand what are really the differences and how to exploit as well the advantages of Reaxys. And that brings me really to my last slide, and that is really, I thank you for your patience. I hope I was clear enough. If not, let me know. And if it was too complex, please let me know as well. I'm happy to answer all questions if there are any. And I certainly can help you with the Reaction Flash app, and if you like. So this is the now possibility to type in questions or to open your microphones and ask them directly to me.
Friedrich, there is several questions in the Q&A tab regarding the Reaxys Flash.
Would you say when I download the Excel sheet from Reaxys structure not appear? Why? I don't know why they don't. I need to find a technical person who can help you. It might be has to do with the settings in your computers, and you might need another visualization tool that allows you to see them. I can, in my it's working. So let's have a. I can check. So somebody asked for the recording. What do you think, Andre?
Let's answer first two questions.
First one is, what's the first one?
Is the application related only to chemical equation mechanism and condition? Is there anything related to identification of compound?
Identification in the app, or?
I think it's a question about Reaxys Flash.
Flash, okay, that's super. So identification certainly you will find in the publications then. I've not checked specifically, but there are always identification methods as well included. So like NMR, or whether it was IR, UV or whatsoever. So it's a possibility as well that you can find some of the information in Reaction Flash. If you have access to Reaxys, you just need to click on Reaxys and then get these information within Reaxys. So let's have further on.
I see the question about the heat map.
The heat map. Yeah, found in. Would you please tell us again where we? Yeah, I can show you. Okay, that was too quick, obviously. So once you have can you see that? When you've done a search like this, a bit more complex, but it's not very complex. It can become very complex if you in deep into Reaxys, you search for documents, should work now. So you have the documents, you go to targets, and here already in this view, you see already here up there, right-hand side top, heat map. And here in my case, I went on and target species, selected those which are all coronaviruses, limited to, and then I had the heat map up here, which I clicked on. Then this window opens, heat map settings. You get the X, Y, and the cell information, and you apply it and obtain it. Try it out. If you can't find it, I will give you a hint again, if you like. So something. Reaction Flash. Okay. Is there anything else coming in at the moment? Do we see anything, Andre? Any other question? But you can contact me anytime if you like, or Andre, to see if you have any questions specifically about organic chemists, inorganic chemists, organometallics, whatever, and searches within Reaxys. And
I see another question.
Can Reaxys help in structure-active relationship? Yes, indeed. This is if you get this type of heat map, if you get this type of heat map, that is already something which is a structure-activity relationship. All these proteins up here are called targets. You can choose, for instance, the spiked glycoprotein. It has not many examples, as I shown, but the next one, as an illustrative example, let me go through again the slide. Sorry, I need to click through it. Wait a second. So if you are selecting just one of these protein targets on top, this is again part of this heat map. And I selected limit to the selected column. That means limit to the selected protein target. If you do so and sort by activity, then you obtain all the compounds that are here now, the substances that are active against the replicase polyprotein 1AB. And that constitutes a structure-activity relationship and is the starting point for a possible drug discovery program in your lab, wherever you are. And as well, what I didn't mention is Reaxys as well allows you to link out to databases that contain X-ray structures of proteins with these little molecules that interact with them. So you get as well a feeling for how the small molecules interact with the proteins. I hope I made myself understood. Have a look. The reaction conditions of a certain reaction you can find directly in Reaxys. It is normally written in the paper or transformation. If you're searching for a reaction, you will find all the papers that contain this reaction or parts of it. And there in the paper and in Reaxys itself, you find the conditions.
And what I can add, this webinar and previously we already did several webinars about Reaxys, and in details we explained, including the topic of reaction condition, browsing the Reaxys data, and this webinar and other webinars would be available on the Reaxys landing page and in Elsevier Africa YouTube channel. We will send you the links to the chat. I see the question about principles of N-alkylation of pyrazolene, and if you have this question, I advise you to go exactly to the Reaxys and try to find the information about it. And in a couple of minutes, our colleague Khalid will show you how right now you can get the access to Reaxys via EKB platform.
There's a last question. Oh, there's a question here. So the idea is to a certain disease. If you are having, you need to have an idea what you want to target. It either is you have an assay available. It could be a protein target. A protein target, you know how to set up an assay and to test compounds against it. So the inhibition activity or the activation energy you can measure or something like that. And you have an idea that this protein might be relevant for a certain disease. So you need to have a working hypothesis to start something like that. This is normally linked to reading literature beforehand, understanding what is going on in similar organisms, like I tried to explain with the SARS and MERS coronaviruses that are already on Earth and already been treated. So I try to explain that. That's certainly a process where you need to read up, you need to talk to others, you need to collaborate. But it is a clear possibility to run such programs, not just in industry, but as well in academia. And it's done in pharmaceutical departments at universities.
Friedrich, I think I have one point to add to your comment about reading documents. For sure, it's important to read the document and understand the idea, but Reaxys can help even with idea generation about the target, because we have the information about substance effect in the RMC, and maybe if the diseases is something very common, for example, cancer or diabetes or something like that, researchers can go to this substance effect field and find, for example, all targets related to anti-cancer drug.
Absolutely. So I agree, absolutely. Reaxys is the source for this information you need to have to generate these ideas. And then you go deeper into it. You understand what proteins are there in the organisms, in the cancer tissue, for instance, and to identify something you would like to address in your project. Absolutely. So it's many of the information can be found in Reaxys.
Right. Colleagues, is there any other questions? Okay, I think we covered all the questions which we have, and now we can ask our colleague Khalid to show how to access to Reaxys using the EKB platform. Thank you so much, Professor Friedrich Kroll, and I hope it was useful for the participants of the webinar, and the recording would be available on Elsevier Africa YouTube channel, on the Reaxys landing page for the Egyptian colleagues, and all participants who are interested in it can get benefits from the recordings. Thank you. And also now we will show some materials how to get the access via EKB platform, and my colleague Alexey Moiseev will show the information about getting the certificate.
Thank you very much indeed. I will now leave the meeting. Thank you, Andre, for the invitation. See you later.
Thank you. Thank you so much, Friedrich.
Thank you, Professor Friedrich. Thank you, Andre. So I'll just allow me to introduce myself once more. My name is Khalid Chalan. I'm an Elsevier core research solutions consultant. I specialize in science direct delay by default, but I'm working with my colleagues here to show a little bit on how you can get access to those solutions that we're discussing today. So we'll be focusing more on the access. I'll be sharing my screen in a second. So just while it a little bit loads, I will just show very quickly the general outlines for this for how to use the EKB portal in general. So just you should be able to see my screen in about now. So these are a little bit of a very quick recap on an EKB portal in general. So the Egyptian Knowledge Bank is really one of the world's largest digital libraries, and it has a very unique point is that all Egyptian citizens get access to resources that are being provided by the EKB itself. Basically, to use the features of AKB, you would only need a national ID or بطاقة رقم قومي. So how it works a little bit. So basically the website is ekb.eg, and once you go there, that's the landing page you will be able to see. What you would need to do is to register, as you can see here. So register أو تسجيل باللغة العربية. So once you create an account, there are multiple levels for accounts that you can create on EKB. So 4 main portals are there: readers, academic, basic education, and kids. A reader means any Egyptian citizen, anyone with a national ID can get access to the readers portal, which has a lot of resources that are available. However, the most premium and the full feature portal is the academic portal, which is designated to scientific research and higher education. To get access to that academic portal, you would need to have a university or an institutional ID if you are a student, and if you are a staff member, a faculty, teaching faculty or research staff member, you would need your institutional email or to activate the account from an institutional IP. However, that being said, because we are during the COVID period, and especially for university students, they can create a researcher account or an academic account with using their personal emails currently, to just help support a little bit with the transition under COVID. It's important to say that regarding most of Elsevier solutions, at least, both readers and academic have access to either solutions that are there for that are available on EKB, or like Science Direct, Scopus, or specialized solutions related to engineering, for example. But however, it also readers have access, as well as the academics, to Reaxys and Embase till the end of July with the current setup, and we'll be pending to see what happens a little bit after with EKB, and then maybe Andre can discuss you a little bit on that. That being said, so a reader or an academic can have access to Reaxys and Embase till the end of this month, as well as Science Direct, Scopus, or other Elsevier solutions. It's worth mentioning that only of Elsevier solutions, only SciVal is exclusive to academic accounts. All other Elsevier solutions are available for both readers and academic accounts. The other two portals, the basic education, it's related to schools, like primary, preparatory, and secondary schools. And the last portal, kids, is for children from the age of 6 years to 14 years old. A lot of fun and learning activities that you can share with your children as well. So to register, you would need the national ID for all accounts. National ID number, and once you've registered, you're sent a confirmation email that could land in your spam or junk folder, and you would need to activate the link or click on the link to access your account with the one-time password that you are sent within 72 hours of registration. Otherwise, your registration is cancelled and you'll have to register again. Important point to add here, since it collects your national ID number, every Egyptian citizen is allowed to create only one account on EKB. That account could start off with being a reader, then becomes a student, then an academic. So you can always shift or change the portal you are assigned to based on the requirements for each portal. So just if you click and register, you see the 4 portals there: the scientific research and higher integration, education, sorry, basic education, readers and kids. If I click on scientific research, There are two sub-portals, one for university research centers staff members and research center staff members, and the other for university students. For university students, it's or for each, you have to put in your personal basic information: first name, last name, email, and confirmation, mobile number, national ID, and birth date. Your birth date, of course, has to match the number on your national ID. And the second page depends on whether you are a staff member or a university student. For university, for both, you have to just clarify your affiliation. And once you have created your account, you can start logging in. And once it's activated, you can actually log in. So that's the landing page for the EKB once you've logged in. So this is an academic search engine that takes your query and runs it against all the databases. It can be useful if you are looking for something really specific, because you will be searching on vast amount of information and also vast amount of searching tools as well. So we would advise that if you are, unless you know something specific, is to actually use the solutions that are being offered by EKB that can give you more specialized and more customized and experience for if you're doing literature discovery, for example, or if you're finding solutions to a question and you don't know, and to like harness the full capacity of the search solutions that you have. So if I click on sources here, and I should be able to see the list of sources by language. If I click on all sources, so these are all the list of publishers that are available on EKB. So as you can see here, so there is, if you scroll down, that's Elsevier, where the solutions that are provided by Elsevier on longer basis, like Science Direct or Scopus, are available. There is also another tab for Embase, and if you scroll down a little bit to the letter R, you'll be able to access Reaxys as well. So, and also you can find SciVal on a portal that is on its own. So here you can see Reaxys and you can see SciVal as well. If I click on Reaxys, I should find a very brief description of what Reaxys is. If I click on the list of products on Reaxys, so this is on a trial period from Elsevier till the end of July. If I click on it, it should be you will be able to log into Reaxys fully. Let me check if I can log onto EKB now to show you, because there's been a problem with my internet connection, so I'll just need to make sure. Also, it could be the pressure, because many students are taking their exams today, and there is a lot of pressure on the EKB servers, especially when it comes to secondary education. As you know, that the general certificate ثانوية العامة are having their exams today, so that might cause a little bit of delays or overloads for the servers at times. So that should, I don't believe I'm able to log into EKB now. So, okay, I can try this a bit within a few minutes instead of getting a timeout. So it might be a problem on my side, or I'll have to look at a little bit more. So till then,
okay, I think we can skip this part. But if you have technical issue, as usually everybody understand how to use it even with the presentation. And with this, I see that there is almost no questions about the Reaxys. If you want to get certificate, Alexei Moiseev write the information in the chat, and we are stopping our webinar, and feel free to contact us if you are interested.
One thing I would need to share very quickly on is this is our landing page with the information for Reaxys. So there are many information you can find on this on Elsevier on elsevierafrica.org/Reaxys. So you can find more about the solutions as well as the recordings for our previous webinars, and so these are our webinars that are available there as well. Also, if you go to our YouTube channel, Elsevier Africa on YouTube, you can find recordings not only for Reaxys and Embase, but for all our different solutions languages, including author workshops as well, and many more in Arabic, in English, and in French, and they are available on this page here. And it also includes the webinars we have been doing on Reaxys and Embase as well. So back to you, Andre.
I think we cover all the questions. Kindly thanks to our participant for your questions, for the interest to Reaxys, and we hope that you can get benefits of using Reaxys till the end of July as a part of EKB trial. And please send the information about Reaxys to all your colleagues so they could benefit from it as well. The easiest way to share the information for them, I think, is to get the link to the Reaxys landing page and explain that on the one of the webinars, it's explained how to use Reaxys and how to get the access to Reaxys via EKB platform. Thank you, everybody.